Good afternoon to everybody. My name is Sandro Cáceres, and today I'm going to present PM2, a process mining methodology. First, let's review our brief agenda. We are going to review a theoretical background, then the problem the paper was intended to solve, the solution the authors gave, and finally the validation of the author's solution. First, let's define what is process mining. One investigation defined it as a discipline that discovers, traces, and improves business processes through extraction of knowledge from event logs of the organization information systems. What does this mean? The main objective of process mining is to improve the business processes. We want to know how the process looks like, what errors we might encounter, and how we can solve them. For this, we have a lot of mining tools that have reached certain maturity levels. For example, we have models like Petri nets or event-driven process change and clustering algorithms that allow us to detect anomalies in the case's execution, and a lot of different tools that we can use. But what is the problem with the tool? What issue we might find when we use them? How do we use these tools in a logical way? Do I have to model first? Do I have to clean the data for my models? When do I mine? Where do I extract the data? What data do I need to extract? Do I plan my project? And finally, do I have to implement the improvements or I just communicate the results? For solving this issue, the scientific community developed frameworks or methodologies. The first framework was proposed by Van Beest. It included first the modeling of the reality in a Petri net model and then the improvement of the Petri net model into a redesign. Then they measured the performance of each one of these models, first the Petri net model of the reality and the redesign of the Petri net model, and validated it to see if the changes made to the model could lead into an improvement of the process. Even though this framework is very simple, it gave us some insight in what the life cycle of a process mining project looked like. The life cycle of the process mining project was an incomplete puzzle and it gave us the first pieces. Now we have a modeling step, a conformance checking step to see if our model is correct, and finally analysis step to get results of what we want to know about the process. But it wasn't enough. Then Rebuque and Ferreira developed another framework that look like this, but I want to focus on three important steps of the framework. Besides the analysis steps and the sequence clustering analysis, we have a log preparation and a log inspection step before them. This is important because they started pre-processing the data to make their analysis better. And also they had a transfer results step to communicate the organization what improvements they could make. This is important, and also another framework included these changes as process diagnosis method, also known as PDM, that considered the log preparation step and the log inspection step before doing any analysis. Finally, after performing this task, they transferred the results to the organization to make the necessary improvements. These added three important steps to our cycle. We didn't have modeling as a first step. We prepared our logs and inspected the logs to know the information we were using was useful and important and wouldn't lead into errors in our modeling phase. And finally, after the analysis, we transferred the results to the organization. But Butterals made the most important contribution to the life cycle of the process mining projects. He called it L star and included a lot of objects and 6 stages that will guarantee that the process mining analysis of a lasagna process will be successful. Let's see one each of these steps in detail. First, we have the plan and justify step. Here we want to answer three important questions. Why we want to analyze this process? Is this important for the company? Is this causing trouble? Do we really want to improve this process? Then the second question we want to answer is analyzing it will benefit the business. In the end of the day, it's everything about profit. So if it's not going to improve the company's revenue or the company's performance, maybe we don't want to analyze it. It's not worth it. Finally, what kind of project are we going to execute? Let's remember that there are a lot of insight that we can get from a process mining project. For example, we can do process discovery actions, we can do process improvement actions, we can detect bottlenecks, we can detect errors in execution that we want to solve. So we need to know what kind of project we're going to execute. What do we want to do with the project? Which are our objectives? Then this methodology considers an extracting phase, which the previous methodologies didn't. The extracting phase consists in combining the domain expert knowledge, the information systems data, and the management info to get an event log, which is our main resource for doing process mining. Then we do the control flow model and event log step. This step can result in three important activities. The first one is conformance checking. In this activity, we want to know if our models are modeling correctly the reality, because if they don't, they aren't useful at all. Then we can do activity discovery. Here we want to translate the reality into a process model in order to analyze it and improve it. The last activity we can do is activity compare. Here we want to compare the performance of two models and see which one of them is the best, of which one of them models the reality in a better way. After these activities, we got our refined models, and we can pass to the next step, that is the integrated process model. Here, we modify our model by adding it perspective, by enriching it. For example, we can enrich it with organizational data. This is which roles take part in this process and why are they important. Then we have the case data. Here we can add to our model, we can improve our model to support noise and detect some anomalies in the execution of the process. And finally, the time perspective, which tells us in which order the events of the process are executed, and also the time it takes to complete the process. We finally get to the last phase, that is operational support, and can give out three possible results. We can detect problems in the execution, and we can communicate them to the organization. We can predict the execution of current cases, and in some cases modify it while they are still executing. Why do we want to predict the execution? Because we might have found an error during the execution of several cases. So if we can predict the execution of the current cases, we can avoid those problems and improve the process while it's still live. Then we can recommend changes in execution. This is when we analyze processes that are not currently executing, and we only recommend to the organization that they should improve the process in some activities or events. Now, this was the L-star methodology, but is this all? There is nothing better than this in the market today. Well, no, because the author of the L-star methodology developed a new methodology that he called PM2. We are going to see what this methodology contributes to the process mining field. First, which was the problem? The problem was that PDM, or process diagnosis method, and L-star have serious limitations when they are implemented. For example, PDM has a low technique usage. What this means, they don't use all the tools that we have to do process mining, and also they doesn't use domain knowledge during analysis. They only use the business experts for the previous phases before analysis. Then we have L-star that is only suitable for lasagna processes. What does this mean? That if we want to analyze an unstructured process or a poorly structured process, L-stars won't be useful. Then it points towards a unified process modeling. What does it mean? They want you to discover just one unified process that covers it all, and that's not always according to reality. And the most important flaw of the two is that none of them considers iterative analysis. They only work like if the life cycle of a process mining project was a cascade. Then, this leads to PM2, but what is it? The authors define them as a guide for organizations performing process mining projects oriented to performance or compliance of rules and regulations. What does it mean? that when we execute PM square, we want to know if a process is behaving as we think it behaves, and also how can we improve it in order to do what we want it to do. The objective, the first thing we need to do when we are implementing PM square is to determine our objectives, because they will determine our questions. First, our objectives can be concrete or abstract, and that's an improvement in comparison to another methodologies. A concrete objective could be to perform improvements on activity A on process B. We know exactly what we want to do. And an abstract objective could be like figure out how process M looks like. We don't even know what it does or what it does looks like or what events are involved in the process. Then these objectives will turn into research questions. We will iteratively refine until we reach concrete questions, and that will result in findings that we can use in our evaluation step. Then, this methodology uses some elements as inputs and outputs and are classified in three categories. First, the objective-related objects. These are the research questions we previously mentioned and are the ones that try to give answers that we are trying to give an answer for. Then the performance and compliance findings that are the result of the analysis step and will help us to get some improvement ideas or refine our research questions. Finally, the improvement ideas are the results of all the project and their final product and have the purpose to improve the process. Then we have the data objects. The data objects are the information systems that are related to the process and the event and data logs that we can get from those information systems. The last element are the models. Here we can use any model we want as long as it reflects the reality. We can use pre-existing models or we can use the models that we are building during the project. The overall process of the project looks like this. We have a planning phase, an extraction phase, the data processing, the mining and analysis, the evaluation, and finally our process improvement and support. We can see that the step 3, 4, and 5 are grouped into a loop. That's because that's the iterative part of the project and we're going to review it later. Also, it's remarkable that this methodology emphasizes that we need the business expert at least during the data processing step and the evaluation step in order to get some more useful insights. First, we have to plan our project. The first step is planning. We have as input our business processes, and then the activities we can perform is first identify our research questions. What do we want to achieve by doing this project? Then we select the business processes that can help us to answer these research questions, and finally we build up the project team. The authors recommend that the project team should be conformed by people that have already a basic knowledge in process mining. The output for this phase are the research question itself and the information system where we can extract data to answer these questions. Secondly, we need to extract relevant data. The input for this extraction phase are the research questions and the information systems. The research question will help us to determine the scope of our project and also to know which event data we need to extract from the information systems. Another activity we want to perform is to transfer the process knowledge into our event data. In this step, we need the help of the business experts to extract relevant data for our project. Then the output of this extraction phase is the event data we want to use for our project. But this event data isn't ready to use already. We need to perform an extra step before using it. We need to process this data. The input for the processing phase is the event data itself, and the activities we do with this data is first we create views of the data, which will be the event logs. These views show us different perspectives of the data depending on what we want to know about it, about the process. Then we can modify these views by performing activities like event aggregation, that is finding a relationship like is a or has a between the views, between the events. Then we can enrich these logs. How do we enrich these logs? By adding external information to them. Finally, we can filter the views. Not all the data we recollected might be useful, so we need to filter it in order to only get the data that will be useful during the analysis phase. Here, the business experts are a very important role during the processing of the data. Finally, after performing these activities, the last three activities in any order or repeat them if necessary, we get our event logs to start analyzing the process. At last, we're ready to mine and analyze. The mining and analyzing process has as input the event logs, and we can perform at the beginning either a process discovery activity or a process analytic activity. The process discovery will show us how the process looks like, and the process analytic will show us the flaws or the errors the execution might have. So, for example, after we do a process discovery, it's good to do a conformance checking to show that we have modeled the reality in a correct manner. And the process analytics and process discovery can lead into the enhancement of the process and show us where we can improve it. Then the output of these activities are the performance and compliance finding. Is the process behaving correctly? Can the process be improved in some event? Then we evaluate the findings we got. With this performance and compliance finding and the process models pre-existing or that we might have built during the project, we evaluate the process. We can do a diagnose activity that consists in finding out why the process is behaving incorrectly. How do we have mistakes? Where the noise is coming from? And also a verify and validate activity that we might have encountered flaws or some anomalies in our process, and we need to verify that these anomalies are really happening during the process. Finally, we validate it with the business experts in order to get some improvement ideas in how to improve these processes. And the output is our improvement ideas that is the main goal of the project, of the mining process project. These last three steps are repeated iteratively. This is the main contribution on the field with this methodology. The evaluation steps could lead into improvement ideas, but with the findings we feed the evaluation step, we could also refine our research questions and feedback the mining and analysis process or the data processing process step in order to get more valuable results. We can do this indefinitely until we get the results we want. Finally, after performing these three steps the necessary times, we can improve the analysis process. The input is these improvement ideas, and we can perform two activities, like implementing improvements in the process and changing its behavior, or supporting operations. The activity of supporting operations is pretty interesting because it implies to modify processes while they are still being executed. What do we mean by this? We can predict the behavior of a process, and we know that there's going to be an error in execution in some step. So we tell the organization that they need to change the flow of the process in this active case in order for it to complete successfully. Finally, the output of the process modification we might have suggested to the organization. Now, how do we know this methodology works? Because it was used for a process mining project on IBM. There were the results on each phase. First, in the planning step, there was one only experienced member in the team. This led into problems while implementing the methodology, but they were solved by doing a workshop about process mining, and all the team members were able to understand their role and their participation in the project. The extraction was made from a SAP ERP system, and the information was 1 month of purchasing process data. Then, the iterative analysis proved itself useful because the project started with an abstract question. They only wanted to see how the purchasing process looked like, so they made an explorative analysis. And this led to 3 concrete questions. They wanted to know how the emergency order analysis looked like, the regular order process looked like, and finally the repair order process looked like. They made 3 different analyses for each one of these processes that they were analyzing. The concrete question originated on the first step, where we only had an abstract question and we made an explorative analysis. Now, can we say this methodology was a success? Yes, but there were a few recommendations the authors made. First, they say that the process analyst and the business expert should work together on an iterative framework because it leads to better analysis results. These two roles are pretty important, and we can take out of the project the business expert during the analysis phase or during the evaluation phase or during any of the phases of the project because they are important. They can give us some insight on which data we need to analyze or of improving ideas are correct. Now, they say that the process analyst and the business expert should have basic knowledge on process mining. If the members of the team don't know why the role is important in the project, they might not do a very good job. And finally, the business expert proved to be essential in the whole project. As we say, this methodology uses the business expert as much as it can to improve their analysis results. These are my reference. Thank you for your attention. I hope you enjoyed this presentation.